This is section 2.6, exercise 30, because everybody should see the silly shadow thing. So in this exercise we have a light. As it beams its light down, it hits our person strolling along here, or maybe they're running, I don't know. And that person creates a shadow here. And I guess we're told that this distance here is 20 feet. And let's see, so it says repeat exercise 29 for a man 6 feet tall, so this is 6 feet here, walking at a rate of 5 feet per second toward the light. I always thought we were told don't go toward the light, but anyway, so here we're going at 5 feet per second, and so and we want to know how the shadow length is changing, right? Because if you're right under the light, you don't really have a shadow length at all, and the farther you stand out, you get this longer length. And so what we need to do is come up with a relationship between the length of the shadow and how far we are from the light. And so, you know, we seem to have at any given time, if we call this 0 and we call our position here x. Now here's where you got to be careful. If we're moving in toward the light, then this is actually our derivative of how fast x is changing. So our dx dt is actually a -5, okay, because we're heading in. X is getting smaller. Okay, so we know that's always 20. And we know that is always 6, and so as we look at these pieces, then you know what I'm interested in is sort of I'll name some things here. I'll just call this A, maybe S for the shadow. That'd be better. S for the shadow length. Well, then I know that because of similar triangles and all that, that the ratio of S over 6 is equal to the full distance here from 0 all the way out to the end of this. So that would be that distance, x plus s over 20. Okay, so I'm looking at the biggest triangle and its height and width. Its width is x plus s over 20, but that's got to be the same ratio as the smaller triangle that has a width of s and a height of 6. And so that's our relationship between where we are x and our shadow length. And so I should be able to take derivatives now of each side. Derivative of that with respect to t is equal to the derivative of x plus s over 20 with respect to t. And so that's just ds dt over 6, or 1/6 ds dt is equal to 1/20 times dx dt plus ds dt. So I need to solve for ds dt in terms of everything else. So I think I'll multiply through by the 6, and so I have ds dt is equal to 6 over 20, which is the same thing as 3 over 10. dx dt plus that 3 over 10 ds dt. Moving that over, I subtract 3/10 of that from 1, and so I have 7/10 ds dt is equal to 3/10 dx dt, and so ds dt is 3/7 dx dt, and dx dt was -5, so our ds dt is 3/7 times -5 feet per second, and so we get our -15. So this is -15/7, or about -2 feet per second. And notice, though, there was no x to put in, so it turns out that if we are walking in at a constant rate, our shadow is also shrinking at a constant rate. That's interesting. Don't know that I ever remembered that, but that's what we get. So that is our, number 30.